welcome everyone. We're going to get started here. Just to give you a little background, my name's Jonah Cowell. I'm a VP at AppDynamics. I run a lot of the product strategy, the evangelism, and work between marketing and product, essentially. My background prior to AppDynamics, I joined earlier this year. I was the lead analyst for monitoring at Gartner for about 3.5 years. Prior to that, I was in a lot of your shoes as a end user and a practitioner running IT operations. A lot of focus on performance and monitoring, but pretty much everything related to infrastructure. So today I'm going to talk about why we're seeing all these shifts in application architectures and some of the broader changes. And you have to kind of understand the macro picture of why we're seeing the microservices thing happen, so to speak. So I'm just going to touch, and you guys obviously saw this similar type of slide that Joe presented. But the reason why I feel it's relevant to frame this conversation is because companies that can build agile software and shift their business models quickly have an inherent advantage over companies that cannot. So it's not just about being software defined, but it's about having the agility in your people, in your process, in your technology, in your software to build these types of innovative systems that keep you on top of your competitors. And similarly, we've seen a major focus on the front office, the systems of engagement, because in order for you to become an effective software-defined business, you have to understand and measure your end user and anticipate what they want. So it's not just about measuring my users, make sure everything's fine, but being able to experiment with your software and see if I change this workflow, if I change this color, is my user more engaged? I'm trying to do anything that I can to keep that user engaged in order to differentiate myself from my competitors. This is how every CIO, every business is thinking from a macro picture. Now, we started to see this trend develop. Netflix kind of pioneered the idea of microservices before it was actually coined as a phrase. So we're going to look at a few different definitions of the word microservice and what it means. The essential idea of this is building a small set of application components that are easily interchanged, that come together to form a piece of software that's an application that users can use. There's a few interesting key areas to pull out of this. Martin Fowler is probably, in the development side and software architecture side, the pioneer of what is a microservice. Adrian Cockcroft, who was the lead cloud architect at Netflix, he's actually an advisor now to one of our VCs, Battery Ventures. So we get to spend a lot of time with him because the concepts of the things that he built at Netflix are inherently what drove the AppDynamics architecture that is built today. And then also some of the other pieces in the Wikipedia definition, which I would call more scientific, talks about the use of generic APIs to communicate between software that was built very differently from all of the components. So when we look at the history of software, sorry, after lunch, you guys are probably like, I don't want any pizza or pasta, but you can kind of look at what we went through in SOA, which was a big push to try to break software into smaller pieces. If we can build reusable components, SOA can accomplish a lot of things in terms of giving us reusability in our software, and that was the push behind it. But the problem with SOA is that it was often burdened by very heavy application constructs. So you would build a big J2EE construct, like a big application, and then expose services that you could recompose. The major difference in microservices is that, similar to the picture here, it's about giving the developers the choice to build and operate each of these services independently. And we're going to talk about what that means a little in terms of data coupling and the general software architecture that microservices represent here. So the reason why we hate monolithic software in general is because it's very complex. So if you're a developer or an ops guy, It takes a long time to understand how the thing works. When you need to change it, it's very challenging because of all the tight coupling that happen in monolithic applications. It's also very hard for test and development. So thinking about running your development environment on your laptop is not possible with these big complex systems. And sure, there's service virtualization and all kinds of other technology that try to make this happen more, but it's still expensive and complicated and challenging. The other piece is that when we need to scale this, it costs a lot of money because we have to provision a lot of different components that are required to make it happen. And we become locked into a single vendor or a single solution, which, as we know in today's day and age of incredible innovation and open source, we can't take advantage of a lot of that. So with microservices, the goals are to build a flexible architecture where services can be easily replaced or rewritten. So it's not so much about standardizing on a language, standardizing on a data store, because the idea is that any one of these services can be rewritten very easily, and yet the application still continues to function. So it enables you to experiment with new technologies without buying all into the new technology per se. This stuff is really hard to do. It's not trivial by any means from a software architecture perspective. It has huge implications on your organization, on the way that you own a problem, own a project, support things, release things. It's very different. To give you an example, an e-commerce example, these are some microservices that you may see in a typical e-commerce system. And the idea is that each one of these is built independently. So if I want to change my user profile service to, let's say, be written in Python when we're predominantly a Java shop, you can do something like that. You can build it in a new language. We see a lot of people that embrace microservices start to experiment with new languages like Go, which is getting popular, especially in the Bay Area. And you can experiment without buying into it and rewriting your whole application with that new technology. So we're going to kind of talk about some of the reasons why organizations are shifting to microservices. So there's a pretty interesting law out there called Conway's Law. How many of you have heard of Conway's Law, just to show of hands? Pretty good. I guess AppDynamics people are much smarter than the typical conference people. So Conway's Law states that if your organization has a certain type of structure, then the resulting software that the organization builds will have the same structure. So if you go back to the way that most of our organizations are structured, we have people that are similar to each other working in a team. So if you're a DBA, you work with DBAs. If you're a Java guy, you work with Java people. If you're a network professional, you work with a network team. So what ends up resulting is that our applications have the same type of segmentation that the people do. And that's what the law states. And there's some interesting arguments why that is or isn't true, but generally speaking, it's relatively accurate. If you want to decouple your applications and get rid of monolithic applications, your teams have to be recomposed in more cross-functional ways. So an example in Agile, when the developers started building in Agile and taking these small teams and iterating quickly on short-term goals, releasing software faster, the ops team had to do the same thing. That's what DevOps is. It's the ops team working with the development team, because they started doing Agile long before the ops guys started doing Agile. And the end result is if you actually have a completely agile organization that can move and recompose itself into different ways, your microservices are a natural extension of that, because these small teams own the life cycle from product planning, product development, deployment, production. And so you end up with this type of microservice construct because it matches your organization. Some of the things that we also see is that there are cloud native patterns that are being used in these new applications. So a lot of the traditional conventional enterprise concepts, centralized databases, sticky sessions, having a lot of state inside an application. Heavy development languages, these are all constructs that are typical in the enterprise. When you look at cloud native, these are definitely very different languages, different technologies, and different capabilities. Now, what we see is that most organizations end up having both of these things. You can't just rip out and throw away your legacy. The legacy systems are still there to stay, but a lot of people, as they develop new capabilities, are building those in microservices that sit on top of legacy apps. This obviously creates a ton of complexity in the environments, but the idea is that we can move faster on where we're innovating and try to kind of cordon off the legacy, so to speak, so that we don't have to manage that and maintain it in an agile way. The other concept is that each of these teams has autonomy. So part of this is culture. In your organization, you need to empower your people to be able to make their own decisions. And if you make the decisions controlled and contained where they're responsible for the outcome, you can give them that type of freedom. And it's interesting because a lot of these cloud native companies, your first day at work at Facebook, you're going to put code into production. That's what they tell you. That's your new employee orientation. You're going to change something and it's going to go into production. So that empowers the employees of these companies to realize that they can make changes, they can make a difference, they can do things. And this is a similar kind of method where teams feel that they can experiment with different technologies. They can try them without betting the bank on it. Because the idea is that if you want to change it, it's easy to rewrite it. It's easy to rebuild it with a different technology. So that's the critical piece, is that you're not buying into something for long term. It's all short-term experimentation and learning. So the other piece is that you get the ability to choose the right technology to fit the problem at hand. Instead of saying you will use Java and Oracle, or you will use Cassandra and Scala, if that's what you're developing in, they have a choice to be able to pick what they feel meets the requirements and that they can support through the life cycle. And this one's a bit contentious in my opinion because it creates a lot of issues. So part of the idea is that this single monolithic database needs to be broken up and coupled with each service. So the idea is that if you look on the right-hand side, each service has its own data store that contains the data that the service needs. So you want to avoid creating new dependencies. The challenge here is consistency. How do I ensure that the data gets replicated and moved between all the different microservices? So you see some of the companies out there doing microservices like Netflix, they tend to use something like Cassandra in terms of how they store and replicate data. They find that helps them with the consistency that they need. Other organizations that pick different data stores for each microservice have to figure out a way how to deal with data consistency. So your DBAs probably have a harder time in terms of data consistency, but the idea is that these things are decoupled so that we can replace individual pieces of our data store without committing to a big monolithic vendor. And a lot of you guys and a lot of end users that I speak to are committed to single data platforms, and we know the pain with that. Whether you're an Oracle shop or a SQL Server shop, it's very difficult to make those changes. So the idea is try to avoid being locked in and being able to make choice. That's part of what's important about this architecture. Now, the other piece is that with these systems, automation is key. So being able to make a code change, push it into production, understand all the telemetry that's coming from your production systems to make sure that the code push was successful is very challenging to do. So there's a lot of automation that's needed. And in most organizations, people have over 10 automation tools. So at AppDynamics, we talk a lot about the fragmentation and monitoring. The same fragmentation exists in automation. You may have one team using Chef, one team using Puppet, maybe some commercial automation tools, application release automation tools. So it's very difficult to deal with the fragmentation. The other piece is that you need to have good engineering practices, continuous integration, automated end-to-end testing. This stuff is not easy to do. There's a lot of great open source that helps, and there's a lot of commercial tools that can help, but it's still a big challenge for most organizations. So now we're going to shift a little and talk about Docker and why Docker is relevant, because it parlays into the microservices. And then we're going to talk a little bit about the challenges that these new architectures bring in terms of monitoring. So not only are applications getting so complex because we're changing technologies and expanding the applications, but we're also creating a lot of complexity in our infrastructure. And this is very visible on the server side. So we started out virtualizing everything. We had virtual server sprawl. We started using container technologies, whether it was Solaris Zones or LXC or some other technology to build lighter weight virtualization. Now, what Docker brings to the table that these other technologies don't is that it provides an API and an interface to be able to make the container do things. And it also creates the ability to have some configuration coupled with the container itself. So it's a lighter weight and more extensible type of virtualization. Not only that, but it's easier to package. The packages become smaller. So hence, it's easier to move these images around. It's easier to run them on developer desktops and machines. We're going to talk about some of the performance gains that you get. Extremely fast to launch these things, to kill them off. So if you build short-lived services, it's very easy to spin these up and deconstruct them relatively quickly. A lot of people think Docker is completely portable. It's not. It's tied to Linux today. So if people say, oh, I can run it on my Mac, you can, but you have to run a hypervisor on your Mac today. Microsoft is investing a lot in making Docker native on Windows, which is in preview already. Otherwise, Linux, it's native. So it's still, it still has some work to do before it's truly cross-compatible among operating systems. A lot of the configuration's in the Docker file, so it makes it much easier to deal with how it should be configured when it comes online. And you need less tools to manage these because they're much smaller copies of the operating system. So you have very little core operating system overlap between containers, which is why they're so small. So to give you an idea, this is a comparison between a native Type 1 hypervisor on Linux, KVM, which is very fast, pretty close to hardware, and Docker. And this is not the best thing for Docker. The boot time obviously is almost half, so that's an improvement. But it gets a lot more interesting when you start looking at reboot time, because I don't have to initialize my operating system. It's incredibly fast to reboot these systems. So you can see here 2 minutes versus 6.5 seconds as a comparison. These are stats that IBM published with SoftLayer. The other piece, when you compare these to bare metal versus a hypervisor, any type of I/O you're doing, whether it's disk I/O or memory type of I/O, is incredibly close to native speed. The reason why is because you're not translating the calls twice. So if I make a system call to access a file with a hypervisor, my guest operating system is making a call to the hypervisor, which is then making a call to the native OS. In Docker, you're circumventing one of those calls. So you're making half as many interrupt calls, I/O calls on a typical system. So it's much faster in terms of the performance. You're not wasting as many cycles on that system. So the overall summary of performance is that the CPU and network are relatively the same. Memory is pretty close to the same as well. Much more flexible deployment. It's easier for your developers to build these systems on their laptops and work independently. So those are some of the reasons why people are adopting microservices, why they're adopting Docker to run these microservices. And over time, you'll probably see a lot of our traditional operating system vendors move away from traditional virtualization to instead running containers directly on bare metal. So there are several companies out there that are building, native Linux operating systems that are just designed to run containers to make it as efficient as possible for you to run these microservices at scale. Now, the problem with monitoring is that you have to understand when all of these individual teams are building these services, they all need to come together in order for us to deliver something to a user. So if the user is conducting a specific business transaction, we have to look at exactly what it's touching, because we don't know which team is responsible for an issue, performance issue, user experience issue. So you need the end-to-end view of what's happening across all of these microservices. So we've seen a lot of demand from customers as they start to think about re-architecting their apps. The end-to-end transaction tracing is absolutely critical to be able to resolve problems and hold the teams accountable. And I'm going to talk about the other things that we built in the product specific to microservices. I'm also going to touch a little bit on the ecosystem here. So obviously, AppDynamics is great, but there's lots of other monitoring tools out there. So we're going to talk about the open source options here. I'll just kind of quickly go through these, but Hypervizor, it's focused on Docker metrics and visibility only. Another great option a lot of people use for log analysis is the Elk stack. So it has a lot of moving parts to it. You can see a little diagram on the right, which is all the different pieces that go inside making the Elk stack work. You have to put agents on the host as well, and it collects logs and other types of data from both the Docker and the native operating system. Now, it doesn't deal with metrics. So Elk is one piece of what you would need to have, and then you would need something to deal with your metrics. On the metrics side, probably the most popular one today is something like Sensu in the open source side, and that will capture all your metrics and provide you graphing and visibility. So you can see you have to build a pretty complicated stack. When you actually look at AppDynamics under the covers, we also leverage Elasticsearch, which is part of the Elk stack. That's one of our data stores. So underneath the product, we do leverage open source, because why would we build another indexing product when there's already a great one out there? The thing that we do is we bring these together so that you don't need to combine 5 or 6 different tools to get the visibility you need. Now, on the issue here is you still don't get any transaction tracing. You don't get any end user visibility with these products. So there's some interesting projects coming up. Spigo is an interesting one that I'll touch on. It's one of Adrian Cocroft's projects, and I'll show you some screenshots and kind of what he's doing and why he's doing it and how it's relevant to microservices. Now, on the commercial side, similarly, there's other great APM products, there's other great log products, lots of mutual customers using things like Splunk, but you have to combine a lot of these different products together. If you want to understand your server and your logs and your APM, your user experience, you're going to need to build a stack of these tools. So some examples would combine some of the other popular APM tools with Splunk, with infrastructure monitoring to get the visibility. We obviously, as you guys know with AppDynamics, we can do all of these types of things, server monitoring, logs, along with the metrics and the infrastructure in one UI. So the other issue is around management, and you saw Jyoti present this slide. He emailed me late, I think it was 2 days ago, and said, "Can I use that slide? I like it." And I'm like, "Sure, go ahead." So this one's amusing because you end up with a huge mess of tools. But each of the tools is useful for one thing. The problem is that none of the teams understand what the other team is doing. So as you build these microservices that exercise a lot of different infrastructure components, your teams have to stop thinking in silos and start thinking in individual areas. So no one wants to let go of their tools. They love their tools. But the reality is that in order for us to work together, we have to figure out how to actually work together while having people keep their own tools. Do you want me to replay that? You guys like that? All right. Replay it one more time. So none of the teams want to let go of their tools. They're good for certain things, but we also have to have a common platform to communicate with. And that's really what we're building. I'm going to skip this because Jyoti did that too. And so the ultimate goal is really we want to figure out how to resolve these issues faster across all of the different silos that exist in most organizations. So how can we quickly identify and resolve the issues? If I can tell the network guy that I'm seeing latency or packet loss between server A and server B and he needs to investigate it and I can provide him context, we're going to get a lot closer to having our teams work together, to having the context of what the other team is seeing, and to have better situational awareness. So we obviously do this with the transaction tracing capability that we have. Being able to look, if you have different teams managing each of these services, you can see exactly where the latency is coming from, exactly which data store is causing the latency in the application. So it's critical to have that view in order to provide accountability for the teams. The other thing that we can do is we have native support. Well, we have an extension that provides support for Docker and collecting metrics, but we can build all the maps of the different components that are contained within specific microservices architectures. We actually run a lot of Docker on our demo environments at AppDynamics, so most of what you'll see in the booths or if someone's demoing a new piece of functionality, all of that actually runs on Docker in our cloud in AWS that we use for demoing and that kind of thing. The other piece, so this is the macro view. If I'm the application owner, I care about the user. This is the big picture. We also have to figure out the smaller picture. So what we built is we built a specific technology called service endpoints. It's a feature in AppDynamics. If I own a service, I'm the service owner, it's my team that has the life cycle, this will tell me how I'm doing. How's my service doing? So this is the micro view of my team, how am I doing? And the macro view is the flow map and the overall user experience view. So you kind of need both of those things because I have to focus on the quality of my service, but I can't lose sight of the end user and the end user experience. To give you an idea of some interesting open source, this is called Spigo, which is a project that's designed to build an emulated microservices environment. So if I know what my structure looks like, but I don't have a visualization of my services, you can actually feed a configuration file, and this is rendered in D3 JavaScript, and it gives you a cool way of visualizing it. Now, Adrian obviously would like to have something like this, which is real-time visibility, which maybe he'll get to in the project, but for today, it's designed to give a simulated view of what a microservices architecture would look like. This isn't driven by real-time data yet, but that's the idea, is he wants to build this open source project that can essentially do what AppDynamics does in terms of visualizing a topology. Obviously, the instrumentation is pretty difficult to do, but that's the concept between what he's trying to build. So with that being said, I have a little bit of time for questions, and we have a mic going around. So any questions, or just raise your hand. And sure, yeah. One sec. Thanks.
Hey, Jonah.
Hi.
You talked a lot about in the your first part of the presentation about people changing languages and such. Do you actually see people doing it? It seems like it would be difficult to manage teams with lots of different languages and such.
Yeah, so I would say that the most common that we see a lot is Node, because it's a event-based programming language. So when you think about building a mobile app, if you want to have communication or real-time data pushes into your mobile app, Node.js is particularly well suited for that, whereas a traditional functional programming language is not. So we see a ton of people building Node on top of whatever language they're building. That's very common in terms of language mixture. But we also see a lot of people building things in PHP, building things in Python. That's why we build these new agents, is because a lot of our customers say, we're a Java shop, but we're doing this other thing. Or we're a Java shop, but we bought this other company that's a PHP shop or a .NET shop. So we definitely see a lot of people mixing languages. We're always looking for the next language we need to support in AppDynamics. But this idea of choice and having developers not burdened by choices that were made a decade ago is definitely changing things. Because if you can't change your culture and let people feel that they're making the right decisions in their own thinking and not jaded by a decision that was made in the past, then the developer's not going to feel empowered to work at your company. They're going to go work for another company that gives them the ability to be creative. So, I mean, that's definitely what we see. Another question? No. One more. All right.
Started experimenting with microservice architectures last year on a program that I was on, and we're a current AppDynamics user. One of the issues that we saw, though, was that when we took a monolithic app with one agent monitoring the whole thing, now if we chop it up into 10 microservices, the standard pricing model is, okay, now we need 10 Java agents.
Yep.
What's AppDynamics doing to help ease that for folks who want to embrace microservices and still leverage AppDynamics?
Sure. So earlier this year, I believe it was March or April, we officially released microservices pricing for Java. So if your heap size of your Java JVM is under 1 gig, I believe we do a 7-to-1. Don't hold me to that. I think it's 7-to-1 or 5-to-1. Sorry, there you go. 5-to-1 difference in pricing. So the idea is that as you break these bigger applications down, you'll need more licensing for AppDynamics, but we are providing licensing discounts for those microservices architectures. We're going to be doing the same thing across other languages, and we're also reevaluating different creative ways to price as applications shift and change. So definitely a concern, and that's why I pushed pretty hard on making that change. Another question?
Well, my first question got answered, but the second question that I had, one of the struggles that I've faced literally in the last week has been when you get the agent installed on one microservice running on the same box, how does it differentiate between the statistics running from one microservice to another on the same node? That was
So, yeah, so there's ways to, in the configuration, to abstract out the node name. And you can regular expression those out in the product that will enable you to separate them. The trick is some people want to have, if you have short-lived services where, let's say, the average life of a service is 8 hours maybe. The problem is that when you kill them and start a new one up, you may want the metrics stitched back together with the old one, which the product doesn't handle particularly well today. It's something that we're addressing. So when you think about killing and starting services, we want to have a continuous stream of metrics versus rebuilding baselines that maybe were totally valid in the last one. So we don't have a way to deal with using the same baseline or extending metrics when services get recycled and changed in this type of architecture, but it's definitely something that we're planning on addressing. In terms of the configuration, if the node names match or if you have some regular expression, you can group things together. I don't know if that answers the issue, but we can talk after too. So, any other questions? I have time for maybe one more. Sure.
Hello, yeah, this is Hitesh, and with microservices, you're gonna be having a large number of JVMs or containers. So how scalable is AppDynamics in terms of supporting the huge number of JVMs, and what is the largest implementation so far being had for AppDynamics?
Sure. So the limit of the controller, we can only do one controller today. The documented limit is about 12 or 13,000 agents in a single controller. We have scaled it up to about 15,000. Now that's the current shipping product. There's a big push to re-architect our metric store, and we have that in release at a few customers. So similar to what I was talking about with Elasticsearch, we're also leveraging HDFS for our metric store going forward. So the idea there is that we're decoupling the event data, which we store in Elasticsearch like logs, the metric data, which we'll store in HDFS, and the relationship data, which we store in MySQL, kind of like how all the communication and the metadata work. So the idea is that when we decouple all three of those pieces, the scalability is infinitely better. With the HDFS backend, we've tested up to about 250,000 nodes, but that's not in customer production, so we don't really have numbers yet. I believe the largest customer that's testing HDFS is about 18 or 19,000 servers in a single view. So that's kind of the answer. We're always striving to increase scalability and visibility. We have customers that definitely want applications that get up to 100,000 servers. We already have demand for that. It's just a matter of when we can have that scalability and fit it into the single flow map and the single controller architecture. So, one more question.
If we develop a set of microservices that are leveraged by multiple applications, and I need to load agents onto each one of those microservices, how do I map from a microservice back to know all of the applications that are talking to the service? Right now, the application will reach out and tell me all the services that it's talking to, but how will the service know all the applications, and I can see that data?
I'm not sure if I exactly understand the question. So we do have, so with the analytics product, every transaction is logged, and you can filter and sort. So that gives you an unlimited way to look at the different interactions that are happening. So you could look by tier type, you could look by transaction type, different ways to slice and dice and sort it. Now, if you're asking how do I get a flow map that looks the other way, today analytics doesn't have the capability of flow map, but obviously that's something that would make a lot of sense. So we do want everyone to be able to recombine the views in AppDynamics in any way that they seem to, that they would want to. So for example, if you're looking at different application flow maps today, but instead I want to see it by data center, like what are my nodes that are in Amazon US East versus US West. We can't do that in flow map today, but we do want to give people the extensibility in the future to be able to recombine the views in any way that they want. But right now, flow map does not do that. I guess I'll do one more question. Anyone?
Any plans to support DCOS for the agents so we can use Microservices and Marathon with your agents?
What was it? Sorry,
DCOS, Data Center OS.
Oh, I'm not familiar with it, so I actually can't answer that question.
Okay, we are managing Docker with the DCOS. It can manage, abstract all the machines and CPU memory, so we don't need the machine agent from AppDynamics, but we would like to still use the Java and other agents.
Yeah, well, come talk to me after, because I'm not familiar with DCOS. So.
Okay, thank you.
Yeah. Okay, well, thank you very much for attending, and hope you have a great rest of the conference. Thanks.